I'll now work on kinetic, potential, and conservation of energy problems, number 4. And in this problem, it says a 4.20 gram bullet. So mass of the bullet is 4.20 grams. Has a speed of 405 meters per second. So velocity is equal to 405 meters per second. Now, part A asks, what is the kinetic energy of the bullet as it leaves the rifle? It's asking for kinetic energy. Kinetic energy is just going to be equal to 1/2 mv squared, but it's going to be in joules. In this case, we don't use grams. We actually have to use kilograms. So converting this, remember, move it 3 decimal places to the left, and you get 0.00420 kilograms is the equivalent mass. So my kinetic energy is going to be equal to, when the bullet leaves the barrel, 1/2 times 0.00420 kilograms times my velocity squared, 405 meters per second squared. Plugging these values into your calculator, you get 344 joules. Now part B of this problem asks, what is the work done on the bullet if it started from rest? So the final velocity of the bullet would be the 405 meters per second. The initial velocity of the bullet is going to be 0 meters per second since it started from rest. Now for work is going to be equal to the change in mechanical energy, so change in kinetic energy, plus change in potential energy. Now this was fired horizontally, so in this case your potential energy change is 0. So work is going to be equal to kinetic energy final minus kinetic energy initial. We already know our kinetic energy final. That's when it's going 405. So this is going to be 344 joules minus, well, 1/2 mv squared. That's initial squared. Well, my initial velocity is just 0. So this gives me my work is equal to 344 joules, since my initial kinetic energy was just 0. Now for part C, it says, what is the average force acting on the bullet if the length of the rifle barrel is 65 centimeters? So the displacement on this will be 65 centimeters, which is equal to 0.65 meters. And it wants to know the average force. Well, in this case, the force is in that direction, displacements in the same direction, so the angle between them is 0. So we can use work is equal to force times displacement. We know our displacement, we know our work. Total work is 344 joules. It's going to be equal to the force times 0.65 meters. Divide both sides by 0.65 meters. Divide this side by 0.65 meters. And you get that the force is going to be equal to 529 newtons. And finally, it says the bullet comes to rest by penetrating 5.5 centimeters of hardwood. What is the average size of the stopping force? So in this one, our displacement for stopping is going to be 5.5 centimeters, which is equal to 0.055 meters. Now notice in this case, the force is in the opposite direction as that of the bullet. So our angle here is going to be cosine of 180 degrees. So that's the difference between the two, which is going to be -1. All right? So what we have here is that force equals, try that again. We have that work is equal to force times distance times cosine of 180 degrees in this case. So our work, it had 344, and it went down to 0. So 344 joules is going to be the stopping times the force times our 0.055 meters times -1 for the cosine 180. Divide both sides by -0.055 meters. Divide this side by -0.055 meters. And at this point, you get that the force is going to be equal to -6,250 newtons. That would be the stopping force applied by the tree.